So I'm at mile 233 on I-15 off the Mona exit here, pointing back here toward Mount Nebo. I just want to talk a little bit about Mount Nebo and the geology of this area. So Mount Nebo is one of the highest mountains in the Wasatch, and if you look at it, it's got kind of a complicated structural feature. Just like most of the Wasatch, its relief is caused, right, because it's part of the fold thrust belt. So within the mountain, there's a really steep fold, and I'll show a little illustration of that so you can kind of see how the rocks are folded. But you can see kind of here behind me, behind this Geneva rock tower here, the cement plant, how the layers are kind of tipping up to the end. Most of those are deep Paleozoic limestones, anyway, Cambrian and above layers. And then you can see up here to the very top of Mount Nebo, right, which is highly glaciated. So you've got a number of Pleistocene glacial cirques. And then really cool if you see pictures of the back end of it, right? You can take the Nebo loop that goes around the backside of Mount Nebo, and it shows the geology a little better. You can see how steeply folded these layers really were, almost like a recumbent fold, like just folded right back on itself. But then, of course, that same fold was then cut by this Nebo segment of the Wasatch Fault, right? So we've got this old folding, which is probably, laramide in age, maybe even severe. So that's like Cretaceous, 100 to 150, maybe at least 65 to 150 million years ago. You had all this really steep folding, and then it was cut across by more recent extensional faulting. Okay, let's go into a little bit more detail about this Mount Nebo thrust sheet, and I promise you will never see this mountain the same, right? So as you're heading south of Salt Lake, or south of Salt Lake, south of Provo, between Utah Lake here and the city of Nephi, right? That's where we're at here in Mount Nebo. So as we zoom up, we'll be able to see on this geologic map a little bit more of the layers that I pointed out in the video, right? So as you're driving by Mona there, you can see all these layers, and you'll see kind of that steep dip that I showed in the video, right? And as you're looking to the north, these layers are in order, right? So the oldest layers, which are the same layers that you find in the bottom of the Grand Canyon. So we've got the tentaquartzite and these Proterozoic, equivalents of the Grand Canyon supergroup. I think the Great Inconformity might actually be in there, but we're right there, in the Cambrian up to the Ordovician and Mississippian layers. But as you head south, what's going on is you have one fold, right? And like I say, this is like basically a taco, right? These layers go down and then taco on each other. And let me just show the cross section so you can see what I'm talking about. So where this cross section goes through, they're just kind of bent, but you can see this dotted line here, right? That shows that these layers, like they're almost vertical, but as you head north of this line, they actually come and fold over themselves, right? Just a little bit. And then the Wasatch Fault cuts that old fold in half. Okay, but what's really crazy though is that you head south, these layers literally do go on top of each other, right? So when you head south toward Nephi, then you have this fold plunging, right? So this northern fold, this kind of a taco, plunges, and then you have a southern fold that comes almost right through Nephi, and these layers are overturned. Okay, you've got the same layers moving up into the Jurassic a little more, and they are completely upside down, right? So how does that happen? Right, you have a fold that overturns completely over itself, right? And there's a reason why we call this the Nebo Charleston thrust system, right? Because this is one of the best places to see it. I mean, you go here, and then you go all the way down to Mount Charleston in Nevada, and then a couple places in between, and you see this massive thrust system peak out, right? It's also in the Pavant range, so you see it here before you get into the Filmora area. You see it in the Filmora Mountains a little bit, and then you can kind of see hints of it as you head down toward St. George, as you go by the Ventura Fold, and then obviously it outcrops in an awesome way there at Mount Charleston by Las Vegas. But I mean, if you are in a class learning structure and you come by this area, they will almost always show these amazing folds in the Mount Nebo area. And also, if you come up Salt Creek Canyon, so this is the one other thing I want you to see that's just really, really cool. All of this kind of pink stuff here, right? If you click on that, this is intrusive masses of European shale, right? So that is the Carmel equivalent. This is a Middle Jurassic shale that was deposited in the Sundance Seaway, right? So it's a really easily deformable, soft shale. And so it kind of like, whenever there's a space problem with these massive folds, it takes up the space. And I mean, just look at the cross section and you'll see what I'm saying. This pink color, that is the shale. Right, and whoever is drawing this cross section, I mean, there's some guesswork here because this is very complex structure. So, I mean, it's really hard to kind of follow what the layers are doing. But we know that there's just these massive layers of like salty, gypsiferous shale, this European shale, that works its way between all the folds and then comes up almost like salt dye appears, right? I mean, it's mostly just completely deformed. So really crazy stuff. And if you go up Salt Creek, you'll see that. And then you can also see the overturned folds. And then the one other cool thing that you see is, right, this fold would have been really high. Like this was the core of kind of a large mountain chain that then got dissected by later basin and range faulting. And you see the evidence of that in these late Cretaceous, early Tertiary conglomerates. So if you look at the top of the range here, you've got these massive Indianola group, right? And you can even see those up Spanish Fork Canyon. This whole Indianola group and Moroni Formation, they are all just thick-bedded conglomerates with fluvial layers that are coming off. Like this ancient mountain chain would have been, you know, twice as high coming up here. There would have been mountain after mountain after mountain shedding sediments to the east, because the river systems would have flown to the east. And now they're going to the west, everything's reversed. But at that time, they're heading to the east into the Cretaceous Seaway, and then later into the lakes that the Green River Formation and the Clarin Formation to the south were being formed in, right? So this really is very cool, very interesting geology. Anyway, thanks for watching.